Flexible filament. What is it? Obviously, we all know that there's a lot of filament out there. One of the most common types is PLA, and that's easy to print with. You don't require a lot of nozzle heat on most of the PLAs, and you don't need bed heat. So things like the Tronxy, if it's noisy, I apologize. It's my CR10, and they're not exactly known to be quiet. It's printing something right now. So a flexible filament is just that. It's flexible. And as you can see, it literally can flex and roll up, and then it's all perfectly fine, obviously. Whereas if you look at regular PLA, it's brittle. It probably will break if I try and... It breaks. It's brittle. It works great. It has its functions. But sometimes you want specialty filaments, such as printing something that can be curlicue. There is ways of doing stuff where people get really creative. None of these designs are mine, of course. But you can do things like this carabiner, which is printed in PLA. And you can see that it's got a flex to it, but it's a spring by the design. As you can see with this piece, it's a hard, rigid plastic, and if I push too hard, it would end up snapping and be brittle. And there's actually, you can see up in here, it's actually splitting. I don't know if it'll zoom, but it's actually splitting from when I put it all together. So anyway, so that's one way. And then other people Make Anything. Devin from Make Anything's actually been doing a lot of fabric type printing. This was another version of stuff. It didn't print very well. I tried to do it on the Tronxy, and the resolution, it just was over extruding. But anyways, but you can kind of create, in this case it breaks, but you can create flexible kind of events. And again, you're using a brittle material trying to create something that flexes. Well, if you're trying to get something like, say, a phone case. That was a guy at work, a friend of mine, mentioned that one of the things he's wanting to do with this new printer that he's got coming in is actually print a phone case. And so this is flexible. It's one of the failed prints, but it's obviously, I split the layer there, but it's flexible. That's the whole point of it. You can basically make things that are like almost like kind of rubbery. Different filaments have different amounts. This doesn't have a ton of stretch, but it's a decent amount though. I mean, it's pretty good. So why doesn't everybody print everything in Flex? Well, it's not easy to print. There's certain things that go badly. There's two types of extruders that are out there, two main styles. Like the CR10 and the Tronxy are what's called Bowden style, which is basically a tube goes from the extruder motor down to the hot end. And the filament gets pushed from the motor and has to just get pushed through that Bowden tube down into the hot end to be melted. The other type is a direct drive, which the extruder motor is sitting on top of the hot end, so it's got no distance and it goes straight from the motor right into the hot end, so there's no pressure. The downside of a Bowden tube is because of that longer distance. It's one of the reasons you have to have retraction larger than a direct drive, because of all the length of the tube, and the Bowden tube can move back and forth and it can cause issues. Well, when you're printing with flexible filaments, if you're trying to push, say, standard filament, and I'm trying to push this through, it'll slide right through, right? I'm pinching kind of hard, and I'll just slide right through because the stiffness of the filament will allow it to support, like pushing a stick versus a garden hose. Whereas this, I'm just barely holding this side over here, and if I try and push through, it won't. I mean, I'm barely pushing through, and I can't because it's too flexible. So that ends up becoming a problem because you end up getting pressure inside the Bowden tube, and then you end up not being able to go from the gear to the opening of the Bowden tube. So if there's any gap, such as this is the extruder motor on the Tronxy. A number of you probably have this, or at least you've heard of it. So this is the extruder motor, and the Bowden system that I was talking about was this white clear-ish tube is the Bowden tube, and it has to push filament from this motor all the way through this tube, and then it melts it into the hot end and creates your print. Well, if you look from the top, you can see this is the gear that actually grips the filament and pushes it through. And even this one's actually not bad, but you can see this is where the filament goes into before it goes into the Bowden tube, and there's a gap. Well, that little bit of air gap, when you get too much pressure trying to push this way, because of a few things we'll talk about, the filament will pop out of that and just blow up, basically. So if the filament pops out, it obviously is going to kill your print. So then the question is, well, what's causing it to pop out? There's a couple main forces that cause it. It's pressure in the Bowden tube from the amount of filament, because the filament is being pushed through the motor, the extruder motor, into the Bowden tube to be melted and pushed through the nozzle. The smaller your nozzle, the lower the temperature, and the different types of materials will melt at a different rate. And if you don't modify, you can actually be pushing faster than you're melting. And if you're using a harder filament like the PLA, if it becomes kind of critical, it can just, the gear can sometimes just pop, and then you'll keep going. You won't even notice anything's happening because it kind of self-corrects, which is one of the benefits of PLA. But if you're doing it with this, the flexible, it ends up popping out of whatever opening or gap that it can do. And for instance, you see this. See that little knot looking thing? That's a piece where a print failed, and because I had just a little bit of gap between the extruder gear and the opening to the Bowden tube, it allowed it to pop out. And once it did that, mine, I've got it the way I've got it covered, it kind of just stopped and it crunches itself up, and then it just starts eventually skipping the gear on the teeth. And you'll never be able to actually print that way. So, what I did was, the first print I printed was I tried to print a phone case, and as you can see, the first layer wasn't bad at all, and then it started printing up here, and eventually it just started getting really rough as it was under extruding more and more, until I finally killed the print. Sorry, I'm watching it's changing layers, not making sure it's still printing well. So what ended up happening, so the first question you asked is, well, why did the bottom seem to print well, and then it started printing the second layer fine, and then it died? Well, again, remember pressure. The idea is that the first layer on most slicers are going to print at a very slow speed, anywhere from 25-30% up to probably usually 50%, because you want to print really slow so you get a good first layer. Well, that's good for flexible filament, because the first thing that they actually tell you is to not print faster than 25 millimeters per second. And different printers will do different capabilities. There's some printers out there that print, you can get like a flexing extruder, and there's things that are designed for it, and of course that's not what we're talking about here. We're talking about just your standard Bowden system setup, like the Tronxy X1 or the CR10 that I have experience with. So what happened? Well, it was printing nice and slow, and when you're printing slow, you're feeding slower. And if you're feeding slower, you're melting quicker, and you don't have as much pressure in the Bowden system. That Bowden tube isn't full and pressured tight with filament. So when it went to the second layer, it basically took this long, increased the pressure, I should say, up until the point that it actually popped the filament free out of in a gap. So if you'll notice, ironically, the second print printed almost the exact same spot. So the first thing I did after the first print, I thought, okay, maybe it's retraction, because see, that's the second thing that can cause flex filament to screw up, is that we know that retraction, or if we don't know, you're about to find out, retraction is pulling back the filament as you're changing locations, and it shoves it back in. So it pulls it back and pushes it back, pulls it back and shoves it, pulls and shoves. And if you're doing that with PLA, it's not a problem. But if you're starting to try and do that with flexible, you obviously don't do so well, which is what we covered earlier. So the first thing I did was, well, I had reduced my retraction to 2. I went from 3.6 millimeters to 2, even though they said to shut it off. So I thought I'd try it, it didn't work. So then I printed the second one with no retraction, and the exact same thing happened. So because the same thing happened, it made me realize that it's definitely not a retraction issue, because I had none. So it was a nozzle pressure problem. So when I did that, what I did was I actually printed a new piece. My CR10 original extruder cap, if you want to call it that, is here. So basically, this is where the Bowden tube connects to, and the filament, the gear is right here. So the gear is rotating and shoving the filament into this hole that's right there. Well, that's where that gap was, and was causing this to happen. It was shoving it all into that little open hole and jamming everything up. So I needed that to not happen. So I went on Thingiverse, and I'll put the link down below, but somebody had already designed a replacement of one of these where they've taken that hole and they cut it larger, so you could put a spare Bowden tube into there, and you cut an angle, so you're basically filling that void or that airspace, so it's going straight from the roller and the bearing that are right here, and the filament is literally directly into the Bowden tube and then off into this and down to the hot end. So I tried that, and it worked really well. It printed great, easy swap out, 4 bolts, not a problem. And I started printing, and this is what happened. So as you can see, it's printing pretty well, and in the upper left-hand corner, right here, you can see that it had started getting rough again, and that was, I believe, overpressurizing the nozzle, so therefore it was starting to under extrude. Sorry about the focus change. So when I started noticing that, it was in the exact same spot on all the prints. So I watched this, and what I did was I cut the speed in half and then reduced the flow, so the amount of filament extruding for a given speed, I reduced all that by 5%. So I'm running 95% flow and 50% of the speed that I set, which was at 25. So I'm running at like 12.5 millimeters per second right now. So basically what you saw there was the whole point of 3D printing. I was having problems. I was working my way through it. Sometimes it requires upgrades. Sometimes the upgrades don't work, really. I mean, it's going to work and be great, but it wasn't really my exact problem because it was still happening. So it was still causing issues because of flow. So you got to take your problems, step through them, and determine what the answer is. And in this case, it was overpressurizing on the hot end. So I just have to go even slower. So is this a super fast way of printing? No. Am I going to be able to get a successful flexible filament print? I hope so. It's doing well so far. We're partway through the third layer, and it's looking pretty decent. And then, in which case, in my mind, I win. Is it the best scenario? Probably not. Would I, if I had access to a direct drive extruder, would I be using that instead? Yes. But for anybody out there that says you can't print flexibles on a Bowden system, I'm hoping to prove them wrong. Obviously, a lot of people out here have already printed them. So it's just giving options. Now I have something that I can try different things with. So there you go. That's about it. I will probably create one more little clip after this thing prints, and hopefully it'll finish up well, and then you can see the end result. But other than that, it's printing quite well, and let's show you. So we're on the third layer. You can see all of this looks really good. That's a drag line because I'm not retracting at all, so there's a little bit of retracting. There's a little bit of issue back here where it's still trying to cover up the original roughness when I saved the print. But for the most part, you can see that I'm, sorry, somehow you'll see it, printing at 40% speed, which you can get to simply by turning your main control knob counterclockwise, and you just keep turning it and it'll turn your speed down. And I'm also flowing at 90% now filament. I probably am going to try the Tronxy, I think, because I like the way it looks, and I'm curious if it'll actually print with that setup. But yeah, so we'll see if it ends up printing out. We'll see, and I'll give you a little clip and let you know. Otherwise, thank you much, and enjoy.